Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Andrea Achille, an Associate Professor of Chemical and Environmental Engineering at the university and an expert in water reuse and wastewater treatment. Welcome, Andrea.
Thank you.
Andrea, people in Arizona realize that we need more drinking water, but most of the conversation has been about sources like groundwater and rainwater runoff. You're working on finding ways to make reuse of water more efficient. What do you have to do to wastewater to make it reusable?
What we use as a source is the domestic wastewater, and we want to essentially close the loop to make that water a new form of water. So we need to treat it so that it's safe for drinking, which means it needs to be clean of all the virus and bacteria and all the chemical organic contaminants. The conventional wastewater treatment does an excellent job so that it's safe to discharge to the environment. We just need to treat it a little bit further to make sure that it's safe for humans in the long term.
At the moment, is any of the wastewater reused by humans?
In general, yes. There are experiences in the United States. Like a famous one is the one in Orange County. It's been running for about 40 years or more. That's called indirect potable reuse. They treat the water to a very high level and then they re-inject into the aquifer and then travels to the aquifer, gets purified further, and then gets picked up to be reused, to be used as drinking water source.
So what are some of the ways that you can think of that our cities and towns can become more efficient?
I believe that to enable water reuse at a city level or a community level, we really need to change our paradigm from a centralized system to a decentralized system, in which each large building, neighborhood, even houses, they will have their own recycling and reuse system.
Why would that be more efficient?
Because turns out that moving water back and forth is very expensive. And that's intersect very well with the old infrastructure that we have, the population growth. If we want to densify the cities, we will need larger infrastructure. Instead, we can make the reuse of the water on site.
How would you go about making a decentralized water treatment plant?
Right, that's the main research question, and I think it's gonna take decades to fully solve this challenge. And it took a lot of time for example, to get very efficient dishwashers or washing machines. That's two examples that I like to give. Like we press a button and the washing does their job. We need to have that level of automation for our water system of the future. Right now, we have like operators on staff in these big centralized systems. We need to move to a decentralized autonomous systems. So research on sensors, automation, machine learning, data science, artificial intelligence, and precise separations.
There are some places that do recycle water, like the space station or
Right.
some of the Antarctic facilities. Are there lessons to be learned from that, or do we need to start over?
No, there are definitely lessons to be learned from that. There are great examples of what we can do. So we can recycle of the water. The challenge is to make it available for the public, for the general public.
How long do you think it will be until we start seeing some available, even on a test basis in Tucson?
I think it's a decade. It's probably long enough that we will see a lot of progresses. If I remember, I've been in this industry for almost 2 decades at this point. And if I think about 10 years ago, we moved a lot. So we achieved a lot of new breakthrough in this past decade. So I think we can definitely accelerate the development of new technologies, new sensors, and especially with these new autonomous systems with machine learning and data science.
Thank you for talking with us, Andrea. Our guest today has been Andrea Achille, an expert on water reuse. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.